Record.
Hello, this is Alec Dobos. I'm going to discuss our project for the Managing Machine Learning Projects project for our course. The first thing I looked at was the opportunity evaluation. We had to introduce our problem, which I wanted to do traffic analysis for urban areas. So the analysis and optimization of vehicular traffic in urban areas can have a profound effect on the management of vehicles in a city and urban areas that experience normal high volumes of traffic. Also, I'd like to describe why I think this is a good opportunity for machine learning. Based on our course, we had three criteria that were good opportunities for machine learning. Is there a problem? The problem is that in many cities and urban areas, there's too much traffic. Analysis of traffic patterns might help urban planners predict traffic control systems such as traffic lights, one-way streets, or for instance, alternating lanes on bridges that have barriers used for configuration and direction of traffic lanes. Can machine learning help solve our problem? I believe it can, yes. Machine learning can help predict and analyze traffic patterns based on the analysis of previous traffic pattern data. And our last criteria was, does someone really care? City and urban planners want to attempt to minimize traffic congestion. Excessive congestion wastes people's time, cause excessive pollution, increase fuel consumption by sitting in traffic and idling, and increase costs for vehicle maintenance associated with businesses. The operating cost of businesses increase and profit margins may be reduced. Then our second question was going to be CRISP-DM, which is Cross-Release Industry Standard Process for Data Mining. So my first thing, I'm going to define my problem. My target user is the driver using the roadways. It could be a personal driver, residential, or a commercial driver for a business. My problem statement is that the problem consists of trying to give a driver the best commute time when they are traveling. Why does it matter to us? Whether it be a personal driver or a commercial driver, excess time spent on a roadway is wasted time to the individual and also a waste of fuel. In addition, unnecessary idling time on roadways leads to increased air pollution. How does society address this today? How is it solved? I believe it's historical traffic patterns reviewed by using roadway cameras and using road sensor devices that capture how many cars pass up on a road during some time interval. Some of the gaps in the current state, I think there needs to be a deeper look and examination that machine learning might offer some insight for us. Machine learning might be able to help predict traffic patterns. Traffic patterns could be based on weather parameters, road sensors, and roadway cameras. Also, construction project input could hinder traffic, which could be part of our machine learning model to give us a better estimate of the traffic patterns. What we will think of success, we need to quantify the expected business impact. The reduction of travel time and traffic analysis will reduce costs for business who are shipping goods by truck and will realize fuel savings cost, maintenance cost of trucks, and resource time for the truck driver. On the other hand, the time savings for a residential commuter will be realized by having more disposable time for things other than sitting on a roadway stuck in traffic. We need to identify constraints. Traffic is a dynamic network system consisting of highways, secondary roadways, bridges, and tunnels. The traffic analysis needs to be quick and continuously updated. Any driver should be able to view real-time suggestions from the traffic analysis system in order to optimize their time going from point A to point B at any time. Translating our impact into metrics, outcome and output metrics, and also defining success targets for our metrics. I believe personally, I took a minimal, I guess a lowball estimate here. I said success will be deemed as 5 to 10% reduction in the average commute time. We have to now identify factors. I believe we need experts for this, right? Our We have to gather our domain expertise. We need traffic engineers, and the Department of Transportation at the local, state, and federal levels will be needed. We need to also identify potentially relevant factors. Factors will include maybe monthly data to determine what time of year we are in, as there might be some traffic pattern changes when grade schools and colleges are in session. Also, it is possible that during holiday seasons, traffic patterns will change, and also during the summer season. Furthermore, the weather will be a factor. In addition, accident hotspots might be examined to determine whether there's a higher frequency or probability of accidents in a particular area or roadway. Our third part of this, describing our solution concept and how it uses machine learning. The solution will use a myriad of roadway sensors, roadway cameras, weather data, and historical data in order to train our model and determine optimal pathways for a particular commute from point A to point B during our commute. And again, it could be either, commercial for business or the residential commuter. I'm also describing how we execute a series of experiments to validate our proposed solution concept. I think what we would do is take small segments of the overall commute, meaning we would take, if you have a 10-mile commute, we might do segmentation by maybe 1 mile at a time, or maybe taking the segment of the interstate or highway and, interpolating, some estimates, and also possibly segmenting the local roadways if need be. For example, if the interstate or highways are jammed up at that time. Machine learning system design. We want to consider our machine learning system design covered in Module 4, as our instructor said. So I'm going to go through that now. System design will include the following decisions: cloud versus the edge. The traffic analysis output for a user will use the cloud. The user will most likely use a cell phone or GPS computer unit in their vehicle to choose an appropriate optimal route for the day. The cloud needs to provide high throughput, and computations needed to occur on the cloud, since it has the ability to perform the analysis and then push the results to a cell phone or in-vehicle computer. Our second part is offline learning versus online learning. Since we have large amounts of data to be potentially analyzed, we should have the retraining of the model done in an offline mode. Our next item is batch predictions versus online predictions. Batch prediction would be pertinent since collected data from cameras, roadway sensors, weather data, and historical data would be analyzed offline. Although if you wanted to include real-time accident data and or road construction data, then it might be pertinent to use online predictions in order to make the system more adaptable to the ever-changing traffic conditions in metro areas. Some of the risks that could happen in production when the user is actually driving and using our model, right? I would say yes, there are some possible some model issues. Weather is certainly a variable which might cause traffic to slow down and thus create traffic jams due to inclement weather. Also, my experience in driving, I've seen even on a bright sunny day, traffic might slow down considerably on a highway due to possible sun glare into the driver's eyes. As everyone knows, you use the sunglasses or sun visor. It's still sometimes a little difficult if you're driving against that sun in the morning or on the commute coming home at night. Furthermore, some other things that might change a typical traffic pattern for a given area could be the time of year. For example, during the school year, grade schools often have children who would need to be escorted to and from schools by their parents or guardians. Many parents work and therefore might stagger or change their time for their own commute to work after dropping off their child in the morning. Consequently, parents who need to pick up their child after school might have to leave work a little early and might even have to go back to work afterwards. Furthermore, construction projects for improvements and maintenance of roadways could impact the flow of traffic. And that's all for my presentation. Thank you.